Okay, this is an example of an equilibrium problem. We have a stoplight here, weight of 100 newtons. Remember, weight is force due to gravity, same thing, hanging from these three wires as shown. So what we're going to do is we're going to solve for the tension force in each of these three wires. To start that, I'm just going to label them. I'm going to call this T1, I'll call this one T2, and this one T3. Normally we use the subscript F sub T for tension, but just to clean it up a bit, I'm just going to omit the F for that. First thing we're going to do is look at the stoplight itself. Okay, always look at the object you have. We're going to draw a free body diagram of only that stoplight. So I'll do that right here. We've got going down the gravity force, which we're given is 100 newtons, and then going up, acting on this, is just T3. T1 and T2 are not directly acting on the stoplight, so only T3 here. We know the net force in the Y direction is 0. So everything up minus everything going down has to equal 0. T3 is going up, the 100 newtons is going down, that has to equal 0, so I know T3 then is 100 newtons. So there's our first result. Now we need to go get T1 and T2. To get T1 and T2, I'm going to draw a free body diagram of the junction of the wires. So like right in here. Alright, so I'll do that down here. We've got this point. We've got T2 going up this way. We've got T1 going up this way. We've got T3 going down, which I know is 100 newtons. Alright, so T2 is at a 53 degree angle. So I know this is 53 degrees. T1 is at a 37 degree angle. So I'll draw those angles in. And I got that from the original picture. Okay. So at this point, the reason why I drew the angles down here instead of up at the top where they're shown in the original picture is when I componentize T1 and T2, I want to keep them separate. Okay, if I componentize T2 up and to the right and T1 up and to the left, I'm going to have these two up components overlapping. It's just going to create a mess. So I try to componentize outwards whenever I can. So over here, T2 is, we're going to componentize that right and up. T1 will be left and up. Remember arrowheads on all your components. Alright, so this component will be T2 sine of 53 degrees. This one will be T2 cosine of 53 degrees. Normally we'd know this value here and we componentize that way. We don't know it. That's okay. We can still write the expressions in terms of sine and cosine. So over here this will be T1 cosine of 37 degrees. And then the vertical T1 sine of 37 degrees. Alright, so at this point pick a direction. In this case I'm going to start in the x direction just because I can look ahead and I know I'm going to have two unknowns in two directions. Alright, so in the x direction I know the net force in the x direction is 0. So what do I have going to the right is T2, whoops, sorry, this should be a cosine. So T2 cosine 53 degrees minus what's going to the left, which is T1 cosine 37 degrees equals 0. Okay? That doesn't get us anywhere because we have two unknowns. We can't solve for anything, so I'm going to look in the y direction. Net force in the y direction equals 0. So everything going up, T1 sine of 37, T2 sine of 53, this is where it helps to have your arrowheads in there. So always draw the arrowheads. So I've got T1 sine of 37 degrees plus T2 sine of 53 degrees. Don't forget we have something going down. We've got T3 going down. So minus, I can just write 100 in there because I know that's T3. That's going to equal 0. Okay, so now we still have two unknowns, but we have two equations. So I'm going to go back to the x direction, and I'm going to solve for either t1 or t2. It doesn't matter. So I'll add the t1 cosine 37 to both sides. So t2 cosine of 53 degrees equals t1 cosine of 37 degrees. And then I'll just solve for t2. Again, you can solve for either one, but I'm going to say t2, oops, sorry, I don't need the cosine there. So t2 will equal t1 cosine 37 degrees divided by cosine 53 degrees. Okay, so I just divide both sides by cosine of 53 degrees. I know that's an expression for t2. I can plug that in for t2 down in my other equation. Okay, so I've got t1 sine of 37 degrees plus t2, which is this t1 cosine 37 degrees over cosine 53 degrees. So that's t2, but don't forget about this sine of 53. And that equals 100. So I'm just going to put the 100 over on the other side. At this point, I've got one equation with one unknown. I should be able to solve it. Do not be intimidated by the trig functions here, sine and cosine. Whenever you want, you can substitute decimal numbers in for that. Okay, sine of 37 is just a number. Sine of 53 is just a number. Okay, in fact, sine of 37 degrees is just 0.602 about. Sine of 53 is 0.799 about. Now I'm not rounding too much here because I want to get a somewhat accurate answer, so I'm leaving it to 3 figures here. We also have, we got sine of 37, sine of 53, we've got cosine of 37, cosine of 53. So cosine of 37 is going to be oh, I knew that one, 0.799. This one should be 0.602. Okay. Now again, you can substitute those in whenever you want. You can do it all the way up here. Okay, so I'll show that. So this will be t1 times cosine of 37, which is 0.799, over cosine of 53, which is 0.602. Okay, so if I did this, cosine 37 divided by cosine 53, we get 1.33 about. Okay, I can just plug this in instead of that big mess. Okay, so anyway, I'll kind of show that. I'm going to show everything at once here. T1 times sine of 37, which is 0.602, plus, and then I'll just go up here, we've got T2, which T2 is 1.33 T1, times sine of 53, sine of 53, 0.799. And that equals 100. So really I'm kind of following that equation down. Okay, so I've got 0.602 T1 plus 1.33 times 0.799, 1.063 T1 equals 100. So now we can just add these two. So we'll get 1.665 T1 equals 100, and then divide by that 1.665. So T1 should be about 60.1 newtons. Alright, now you may get slightly different numbers depending on where you round, and that I've rounded a little bit throughout here, but you should get pretty close to that number. I think without rounding you get about 60.9 newtons. I got 60.1, really similar. Okay, now we need T2. Okay, so I'm going to use this expression up here. T2 equals 1.33 T1. So T2 equals 1.33 T1. T2 equals 1.33 times 60.1. T2 equals times 1.33, 79.9. Alright, so there we have it. We've got T3, we got right at the beginning, 100 newtons, and then we did some math, some substitution. Again, you have a little flexibility in here. When you want to substitute your decimals for the trig functions, you can do it whenever you want. You could do it up in your free body diagram even. Okay, so this would be like 0.799 T2. It's totally fine. But just sum everything up in the x direction. You know it has to equal 0. Right minus left equals 0. In the y direction, everything up has to equal everything down. So we've got everything up minus what's down, the 100, equals 0. Alright, substitute where you need to. Then we got T1 and T2.